Good morning, everyone. We are live from Beehive Industries in Arapahoe County, and I am joined by Gordie, who is absolutely fabulous, and it's intriguing what we are witnessing here today. Tell us your role with Beehive Industries and what is going on with your wonderful announcement.
Yeah, thanks, Sarah. So I'm the Chief Product Officer for Beehive. So essentially, I'm responsible for commercial activities, trying to sell what we're doing, but also managing the programs once we do get the contract. So basically, we focus on applying additive manufacturing to develop jet engines for unmanned applications.
And you all are the very first that are doing this.
As far as we know, we are. Yes,
That is so amazing. Well, we'll walk a little bit here, and you have a couple different hubs. I believe you have 4 different locations around the United States, correct?
Yep, that's right.
Okay.
So we have, obviously, here in Denver, we have a facility in Cincinnati, Ohio, another one in Knoxville, Tennessee, and then a smaller facility in Northern Ohio.
Okay,
well. Yep.
But this is the main headquarters.
This is the main headquarters.
In Denver.
That's right. Yep.
And how long have you all been here?
We've been here about 3 years.
Okay.
In this facility, about a year and a half.
Okay.
Yep.
So this is pretty amazing to be the tip of the iceberg.
Yeah, that's right.
And to be having jet engines, which has never been done before.
Yeah.
Well, take us in here really quick, because this is the hub where all of the brains sit with all of their equipment. I mean, explain what goes on in here.
Yeah, so essentially, this is where when we run the engines for testing, the team is in here kind of monitoring the test as it goes along. So typically we have basically a test leader this is actually the throttle like you would have in an airplane.
Nice.
He's actually making the engine run. And then we have subject matter experts in each one of these chairs that are monitoring whatever the thing is that they own, right? So it could be, is the compressor performing properly? Is the combustor lighting and staying lit? Is the turbine doing what it's supposed to do? So basically each one of these stations is a different engineer that's looking after some key aspect of the engine.
That is amazing. This is where the brain headquarters are.
It's the hive of the beehive.
The hive of the beehive. I love it. And what we learned earlier is that this is much more efficient than what a regular engine is.
Right, that's right.
Less parts, so less cost, which is pretty amazing. So from kind of start to finish with just the building process, how long is that?
So the total manufacturing process of an engine will take about a month. We don't make them one at a time. We're going to be making them tens at a time, or at some point maybe hundreds at a time. But from the time we put powder in the first machine to when it's in an engine ready to ship, about 1 month of time.
That's incredible. One engine usually takes years to complete.
That's right.
So to have a month to do this is extremely efficient.
That's right. Yep.
Well, here is the baby right here, or not so baby, depending. Yeah. So tell us what we are looking at.
Yeah. So this is this was really the first engine that we started developing. This is a 500-pound thrust engine for kind of large unmanned applications, I would say. And we kind of designed this engine to be able to grow up in thrust for different types of applications. So right now it's running about 500 pounds of thrust. It can scale up to about 1,000 pounds of thrust. So this engine, we actually put this in here at the beginning of November. It came to test actually about a week ahead of schedule, which is really nice. That's not usually the case, but it got here about a week early. So the team has basically been walking from kind of the minimum thrust level, like starting it and then starting to walk up to maximum thrust. So right now we've been up to about 400 pounds. After you guys leave, we're going to do a couple of checkouts, and then we're going to start pushing back up to 500 pounds of thrust. So the engine, what I will say is it's a little bit like a dog with long hair, and once you get it wet, it looks really big, and then you get it wet and it looks much smaller. A lot of what you see here is not really what's going to be installed in the final application. It's just here to help us monitor the test.
Okay.
So what you really see is this is the engine. Like this part here is the engine. This is actually a test enabling piece of hardware. This is essentially a bell mouth. So the flow comes through here. This is just a cover. We can take this off. We can look inside. But if you look down in there, you can see the engine inside.
Oh, wow.
Yep. So the air comes in this way. The engine is this metal bit in the middle. And then all of this other claptrap, right, is essentially instrumentation or test limiting hardware that allows us to conduct the test in a very specific way.
Okay.
But at the end of the day, basically what you have is this part here is really the heart of the engine.
And this is what makes you all different, correct? Because
that's right.
Because people are 3D printing, and that's been around for roughly a decade.
That's right.
And so, but you have the moving parts and the fans, and you all are again the first ones to
That's right.
implement
That's right.
this.
So in this case, like all of it's called turbo machinery, but all of the main components that make up the engine are 3D printed. So typically, I think the most up to this point has been 20%, 30%. This engine is 95% 3D printed. Essentially, the only
That's
thing we
amazing.
don't print is there's a little shaft in the middle of the engine. We don't print it because it doesn't make financial sense to do so. It's pretty easy to make conventionally, so we make it conventionally. But the rest of the engine is 3D printed. And then when you, again, like we were talking about earlier, if you design something up front, knowing that you're going to manufacture it using 3D printing, it changes the way you design it. It changes the way you kind of develop it and test it and manufacture it.
Nice.
And so in the end, what we see is we see about 25 to 30% better fuel efficiency than a conventional engine.
Wow. Okay.
These engines cost roughly half or less, 50 to 60% lower cost than their conventionally made competitors. We get to test a lot faster. So this engine, from when we had a blank sheet of paper on a drawing board to when we had an engine in this test cell, it took us 13 months. That typically takes 4 years, 5 years.
Wow.
So you get to test a lot faster. And then, as you saw on the tour, right, we can make many of these simultaneously in the printers at a time. So we can scale up very rapidly. So we go from making a handful now, we're going to be making 500 probably in 2026, or 500 to 1,000, 5,000, 10,000.
You are changing aviation substantially and very, very quickly. And you all just received a contract, correct?
That's right. That's right.
Brand new, hot off the press.
Yeah, just a couple weeks ago, we announced our first big propulsion contract. So it's with the University of Dayton Research Institute, ultimately funded by the Air Force. They're our final customer. Wow. And the idea is to take all the things that we've learned on this prototype engine and consolidate it down to a smaller 200-pound thrust engine that'll go into a family of unmanned vehicles.
This is amazing. Well, thank you for walking us through this. I've been fascinated for weeks to come in and actually get to see this firsthand. So Gordie, thank you. And this is absolutely amazing.
Yeah, thanks.
Guys, make sure you check out Beehive Industries, because this is an industry that is going to change the world.
And we're hiring.
Oh, good. Come on in, apply for a job.